Okay, so we're rational exponents. Here's the big thing we're looking at today. And again, this is something that we've already done. There's two ways to go for this one. There's a forwards and a backwards. We've already done the forwards part. It's the backwards part that we've got to work on to make sure everybody's okay with. Okay, so if we have an expression that's in radical form, that's the nth root of x to the p power. And this is the part we've already done. We didn't call it this, but we already kind of did this part of it. They're going to ask you to rewrite these in exponential form. Okay, now, but flash back to what we were doing in variables. What did we say if we were going to simplify these variables? What did we do with these two numbers?
Cancel them.
Okay, by doing what? Dividing, right? So when we did the p over n, we didn't call it exponential form, but that was them taking a radical and rewriting it in exponential form. So they're going to have you do a couple questions. We're rewriting this one, so it's not like it's going to be any huge deal. This is the stuff we've already been doing. So this part of it should be really easy, for what we've got on this one. Okay. So just some examples on this one. And some examples, they're not going to ask you to do anything other than just rewrite it. And again, the rewriting part is kind of building up to some things we're going to do a little bit more today, and then we'll finish it up tomorrow with the solving part that we'll do. So if you have the square root of 36, again, we're going to rewrite it in exponential. All right, and we're not going to solve, even though we could do the square root of 36. We know that answer would be 6, but we're not going to solve it. We're just rewriting it in the exponential form. So if they ask us to rewrite it in exponential form, understood base here would be 2, correct? Or the index would be 2. So if we rewrite it, it's 36 to the first power divided by 2. So just make it 36 to the 1/2 power. If it's the fourth root of 17, again, rewriting it in exponential form, 17 to be to the 1/4 power. Okay, and if it was third root of x squared, x to the 2/3 power. All right, and again, we've already been doing that because of the way and again, this is where the textbook went a different route. The textbook had the whole route of grouping them together and doing stuff. It's like, okay, that's great, but let's just go ahead and do what we're going to do later because you're just going to do division with these problems. All right, now for the second part of this one, this is where we're going to go the opposite way. Now we're going to go from radical form to exponential back to radical for this thing.
This is important stuff right here. I'm going to send you 2 text messages.
All right, so now we're going to go the other direction. We're going to write in radical form. Again, we're not worried about any simplifying just yet. We're just practicing on rewriting these. So we've got x to the 3/7 power. So now the answer's got to have a radical in it some way. Okay, again, what you're dividing by on the bottom, that has to go on the outside for the root part of it. Everything else, just go something like that. Now, and with some of the solving that we're going to do, that's the answer that we've got for wanting to rewrite it. Later on, we're going to have some of these that we're going to do where you actually have to. Sometimes you may not want to do that part at first. You also can have it kind of set up like this. That tomorrow, this is kind of the way you want to think about this one, of doing maybe the 7th root of x and then to the 3rd power. So you technically could do this one either way, but if you're just simply rewriting it, that's the answer we're looking for. Tomorrow when we're solving it, you probably more want to think about that you'll do the root part of it first, and then you can take the root part and then do it to the 3rd power. But you can kind of go either way. You can do x to the 3rd and take the 7th root of it, or you can take the 7th root of it and then do that to the 3rd power. So just kind of, be on your toes that we can go either way there. So let's do w to the 5/8. So again, denominator goes on your index, W fifth to go there. And again, you can kind of go either way. We can do the 8th root of W to the 5th power. All right, throw your curveball here. What if it's a negative exponent? Oh no. No. Does anybody remember what happens if we had does anybody remember what happens when we had x to the negative 2 power?
It's imaginary numbers, right?
No, not quite.
That's square root.
Yeah.
It's like undefined because you can't.
No, not quite. Or how about this? What if we did 4 to the negative 2 power?
Oh, that's 16.
All right. So 4 squared would be 16. Do you remember what happens when we did 4 to the negative 2? It's almost the exact same answer.
If it's like even in the odd numbers?
No, not quite. Somebody, I thought we were on it there. You're getting close. Same thing, except for we got to make it a.
You can't make it negative. It's impossible to make it a negative. A fraction?
There we go. Got to make it a fraction. Got to make it 1 over on that one.
No, I think no. You got it after you did the slide. No, you did it as soon as you did the little line.
But he was on the right track, so. He's going to try to steal it.
No,
Okay. Okay, so basically on this answer, whatever answer you get here, it's the exact same answer. You just have to make it 1 over that answer. So if it was, so again, if it was x to the negative 2 power, it would just be 1 over x squared. So if it's a negative exponent, you just have to take whatever the answer normally would be and just write it as a fraction, so it's 1 over whatever that answer would be that's there. All right, another curveball. X to the 0.2 power. All right, what is 0.2 as a fraction? What place is that in? That's in the tenths place, right? So that's the same thing as 2/10. Can you simplify 2/10? That's 1/5. Okay. And then now we've got this in a simplest form. Now we can rewrite it to make it the 5th root of x to the first. But if it's x to the first, we don't have to put the first power, so it's just the 5th root of x. Okay, and about the only other thing that possibly could pop up on these is they might give you a mixed number. Or sometimes when you're working through some of these exponents and things you're doing, you may get a mixed number. But again, we still want to put it in like just a fraction form, so change it from a mixed number to an improper fraction. Okay, so then we make it the square root of y to the 7th. And again, if the index is 2, you do not have to put the 2 there because without the index, it's always an understood 2. So that one, you can leave it just like that where it's square root of 7. All right, now here's where they're going to kind of go a little different route on this one. That for this part of it, we're going to ask you to simplify, but probably more than likely they're going to say to simplify without using a calculator. So they're probably going to say to rewrite it in radical form and then simplify it. But there's really and we'll show you after we do a couple of these. There's really a lot of different ways you can go on these problems. It's really just whichever way kind of starts to look the best for you. So after we show you a couple of these, we'll show you some other rules you can do. And then really at that point in time, it comes down to that there's 2 or 3 different ways you can solve a problem. It's just whichever way you visually can see that's the best way that you want to do. Okay, because right now, probably at this point in time, if we've got 64 to the 1/2 power, most people aren't really looking at that and seeing what it is. But if you were to rewrite this one in radical form, that would be the square root of 64, right? Again, 2's not needed, so we can, because it's square root, so we're good there. What is the square root of 64? There you go. So that's all we're going to do. Now, you do not have to worry about pluses or minuses in this case. I know we're taking square root, but at this point, we're assuming that all the answers could be positive. So the only way we would worry about a negative is if we were doing like a third root of negative some number, then we do that. So you do not have to worry about any plus minuses on this one. All right, let's do 11 to the 1/2 times 11 to the 1/2 power. All right, again, if we were to rewrite these, that would be square root of 11 times square root of 11. Yeah, so if we do 11 times 11, that's 11 squared. But because we're in the square root of 11 squared, it cancels, so we get just 11. So we square root the 121 to then give us 11. So 11 times 11 is 121. If you do that, it's a nice perfect square, so the answer is just 11. All right, so let's go 3 to the 1/2 and then 12 to the 1/2. All right, so rewriting it, we've got square root of 3 times square root of 12. 3 times 12 is 36. Square root of 36 is, there you go. Okay, now, and all these have come out nice and neat and perfect. Let's give you some where it's not going to be nice and neat and perfect, because not everything is going to come out, exactly wonderfully, every single time when we do these. Let's do 4 to the 1/3 times another 4 to the 1/3. Okay, so if we rewrite it, that's the third root of 4 times third root of 4. Okay, so third root of 4 times 4 is 16. All right, if you check it with your calculator, that is not a perfect number when we go cube root on these, so this is where we're going to have to take the 16 and break it down. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. So it's the cube root of 2 times 2 times 2 times 2. All right. And again, because we got all the 2's lined up there. Third root means we need 3 of a kind. There's our 3 2's there, so that 2 will get out. That 2 doesn't have any other buddies, so he stays stuck on the inside. So then it's 2 times third root of 2. Okay. So now here's where we're going to kind of change gears just a little bit with this. So there's the rewriting part back and forth. Some of these problems, and a couple of these problems back here would be problems that if we're going to show you some properties, if you do those, you might can get the answers quicker by doing them one way versus what we did here. But again, this is the point where we start to get where you've got, especially when we throw the things in the wall, there's 2, 3, 4 different ways you can work problems and still come up with the correct answer. So there's not going to be one set specific way. It's going to be more of, it's just looking at a problem and figuring out what you think would be the best way to get there. So we're looking at its exponent properties, but again, you can always take it and rewrite it in radical form. But so technically they're exponential or exponent properties. But again, just realize that we could always rewrite them in radical form as well. But in this case, we're going to look at it more in exponent form. All right, so basically here's what it is. If you have two things that are both to the same base and you're multiplying them together, the shortcut is, instead of rewriting it back in radical form, we can just take those exponents and add them together. And again, y'all been doing that before, so that's not any big deal, because if you had, x squared times x to the 4th, we would just make that x to the 6th. Okay, so that's not really anything new. Now we're going to do it with numbers more in a little bit, but that's kind of the thought process you want to have as we're going through this one. If you have some number raised to a power, raised to a power. Again, it'd been great if we'd come straight out of Algebra 1. Most of y'all came out of geometry, so that's where we kind of lose a little bit. Anybody remember what to do with those two? If you got a power raised to a power? There we go. You just multiply those two things together. Yes.
Is algebra 2?
So if you had x squared to the fourth power, you just multiply 2 times 4 and make it x to the 8th power. All right. Now, and same thing goes on this one. If you had two different things multiplied together to some power, it's almost like distributed property because technically you would have a to the first power and b to the first power. So when you get finished with this one, you're going to have a to the power and then also b to the power. So if you had x squared y to the 5th power, so for the x, you would do 5 times 2 and make it to the 10th. For the y, again, understood 1, right? So that would be y to the 5th power. And that's the one, a lot of times people forget about that one. They'll forget about the understood 1 power, and that's the kind of sneaky part as you go through some of those. All right, this part, we just talked about this one, but here's the actual property for that one. If it's a negative power, negative exponent, you just rewrite it as 1 over that number. So again, if it was x to the negative 2 power, it becomes 1 over x squared. All right, and then the last different property we have, and again, this one we've already done some of this, so this is not anything new for this one. If you have a to the m power over a to the n power, we say if you're dividing, what do you do with the two exponents? Subtract them. There we go. Heard somebody couldn't tell who it was, but we got to subtract there. So it's a to the n minus n. That was you. Keelan says it wasn't you, so it's not. Okay. Okay, so again, if it was, y to the 7th over y squared, you'd make it y to the 5th. Oh, now, good question on this one, kind of extension on this one. What if on that one, and this is just a what if here, just kind of think your way through on this one. But what if that number, instead of being y to the 7th over y squared, what if that had been y to the 7th over y to the 20th? What does that do?
What did you say?
So let's say instead of being y squared, what if that had been y20 on the bottom? Yeah, you still subtract, right? So that'd be y to the negative 13. But what do we do with a negative exponent? There you go. So you got to put over 1. So then that answer would become 1 over y to the 13th power. So as you're going through some of these, everything we've done before when we subtract them, it was always going to be positives. Now you may get some negatives. And again, basically the kind of thought on that one is wherever the bigger power is, if you subtract the two numbers, those leftovers have to be there. So for this one, y7th was in the numerator. The leftovers are in the numerator. If we made that y20, 20 is the bigger number. It's in the denominator, so your leftover would be in the denominators. Okay, so that's kind of the thought process we've got going. Okay, so now here's what we're going to do. We're going to actually give you some different actual numbers and not just all letters on this one, just the variables, and work through some of these. And this is where, again, they're just going to ask you to simplify. So there's more than one way you can get these answers. It's just the fastest way that you can get there, the way that you think would be the easiest way to get there. Okay, so we've got 8 to the 1/3 and 8 to the 2/3. Then again, you could rewrite this as a third root of 8. You could rewrite this as a third root of 8 squared and go back and put those two things together. But the easier way is just to add the exponents. So it's 8 to the 1/3 plus 2/3. What is 1/3 plus 2/3?
3/3 is 1.
Yeah, that's 3/3, and 3/3 is the same thing as 8 to the first power. So there you go. So now you go from taking a radical and breaking it down and working through and doing all the stuff with it. Now you're just adding and subtracting fractions, which hopefully is going to be a little bit better for some people instead of doing that. Okay, so let's do 5 to the 1/2 power to the 4th power. Okay, and again, you could rewrite this as the square root of 5 and then do the square root of 5 times the square root of 5 times the square root of 5 times the square root of 5. Or just know in this case that if we've got these two, a power raised to a power, we just multiply those two things together. So half of 4 is 2. So we get 5 squared. 5 times 5 is 25. There you go. So those properties are there just to hopefully kind of speed the process up as we go through this. And here's where the property really kicks in on this one. Because if you go back to what we were doing a couple of days ago, for example 3, if we do square root of 3 times the 4th root of 3. So flashback a couple of days to when we were adding. So wait, sorry. We're multiplying these. We said if you're going to multiply two different radicals, number one, the indexes have to be the same. These indexes are not the same. So a couple of days ago, this problem, they'd say it's cooked, but this problem would have been cooked. You couldn't do anything else with it. Okay, but now what we're going to do is we're going to rewrite these in radical form. So this would be 3 to the 1/2 power. This would be 3 to the 1/4 power. So now that we've got the same bases, we don't care what the radicals are because we've got it written in exponential form. Now we can just take these two things and add the exponents together. So we can make that 3 to the 1/2 plus 1/4 power. And if anybody ever listens to this video like 6 months from now, they're going to hear me say cooked in the video, and they're going to go, wow, that was such a lame word to use there. Yeah, because the words, the slang lasts for you got about 2 months before it goes away and it's no good. So give it a couple months and nobody will be using cooked anymore. It'll be something else. Okay, so 1/2 plus 1/4. If you get your common denominators, that's going to be 2/4 plus 1/4, right? So adding those together, that would be 3 to the 3/4 power. And if they ask you to leave your answer in exponential form, that would be your answer that you have. If they ask now, they may ask for it in exponential form. If they happen to ask for it in radical form, really easy. Then you make it the 4th root of 3 to the 3rd. So again, bottom number, denominator becomes your index. This becomes your power. And then you could say, all right, well, 3 to the 3rd will just be 27. So that answer could just be the 4th root of 27. So there's your answer in exponential form. There's your answer in radical form. And they don't look anything alike, but yet that's the answers that we're looking for. So again, they should tell you which one they want, whether they want exponential or whether they want radical as you go through this thing. Okay, now here's what we got to throw in. So that's the basic idea of everything. Here's where we're going to throw in those few little details just to kind of keep you on your toes as you're moving through some stuff. So here's where they try to get sneaky with you. All right, so let's go with 16 to the negative 2.5 power. All right, so first thing is, we got a negative number. So first thing is I would fix that and rewrite it as 1 over.
Teachers, please.
Okay, so with the negative exponents, 1 over 16 to 2.5. And this is where, again, you've got to kind of think that if it's 2.5, okay, that would be 2.5. And if it's 2.5, you could rewrite that and make it 16 to the 5 over 2 power. All right. And you may be going, well, I don't really know what that is. So a lot of times it's kind of, you almost work it in the opposite direction. If it's 1 over 16 to the 5 halves power, that's 1 over the square root of 16 to the 5th power, right? Now, does anybody know what 16 to the 5th power is? Probably not. Does anybody know what the square root of 16 is? That's 4, right? So that becomes 1 over 4 to the 5th power. And now, you probably don't have 4 to the 5th power rolling in your head, but that's still a lot easier than doing 16 to the 5th power. So that's where if you got something like this that's in the exponential form, you can either do the radical part first or you can do the power part first. Most of the time, it's easier to do the radical part because if we can do square root of 16 make it 4, and they might just let you leave the answer that way. You could try that and see. If not, then you go ahead and do 4 to the 5th power, and then you find out that that would be 1,024.
Coach, I know what 16 to the 5th power is. It's 1,448,576.
Just right there on the top of your head, right? Just,
Yeah, oh yeah,
yeah.
yeah. Top
Okay.
of my head.
Yeah. Okay.
Okay, so can I use a candy gun?
No.
I told you to say that.
All right, let's go negative 32. Haven't thrown a negative number at you yet. So negative 32 to the 4/5 power. All right, and again, most of these cases, whatever way they give it to you, you probably want to rewrite it the other way. So if it's here, and again, that doesn't really give me a whole lot. I can look at this and I'm like, I don't know what that is. So let's rewrite it as the 5th root of negative 32. And notice the number's in parentheses to the 4th power. And again, if you check this one, I don't know what negative 32 to the 4th power is. So really on this case, I'm going to do this part. I'm going to do the radical part first. Because again, I know the 5th root of 32 would be 2. So if it's a 5th root of negative 32, that would be a negative 2. And then we've got negative 2 to the 4th power. So now it's just negative 2 times negative 2 times negative 2 times negative 2. If you do that, that should be a 16. There you go. So it would be a positive 16 because of the 4th power there. All right, this one's a little bit shorter. All right, we've got 16 to the 3/4 power. Okay, again, if that doesn't make any sense how it's written, rewrite it in this form. And again, I don't think anybody knows what the 16th to the 3rd power is. I don't know what it is. But again, if you look at the 4th root of 16, that's just 2, right? Because again, look at the problem back here. We did 2 to the 4th power to get 16. So it's the 4th root of 16. That should give us 2, just working backwards there. 2 to the 3rd power. There you go. That's just an 8. So if they give it to you one way, just rewrite it the other way and think about how it looks and then see what you can get out of it from there. 3 more. So 3 more to go and then we're done. All right, this one. One more, just a number, and then we got a couple. We're going to throw in some variables with it too. All right, let's do 9 to the negative 3.5 power. Okay, so a couple of things you can do with this one. If you want to get rid of the negative first, you can make it 1 over 9 to the 3.5 power. If it's 3.5, again, got to put that in fraction form. That's 3.5. And in that case, it's a mixed number, so we got to make it improper. So that's 1 over 9 to the 7/2 power. Okay, so we got 1 over. But again, if we rewrite that now in radical form, that's the square root of 9 to the 7th power. Because again, we've got the understood 2 that we go here that we don't have to have. And does anybody know what 9 to the 7th power is? No, we don't. Does anybody know what the square root of 9 is, though?
3.
3. There we go. So now we got 1 to over 3 to the 7th power. And again, they may let you just leave the answer like that.
9 to the 7th is 4,782,900.
And then when you square root that number, or you do 3 to the 7th power, that would be 1 over 2,187. Okay. All right, the last two problems. We haven't done anything with variables yet, so we're going to bring in some numbers, but also bring in variables at the same time because we need to get a little bit of practice with that. All right, so the last two. Here we go. So for this one, let's make it 8x to the 15th power to the negative 1/3 power. All right, and again, it's the whole thing to the negative 1/3 power. So first thing is, if you want to, and again, a couple options you can go. Because it's to the negative 1/3 power, the whole thing, you can think about that as being 1 over 8x to the 15th, just to the 1/3 power. Okay, and then you've got your distributive property. So we got 1 over. So again, it's 8 to the first power and x to the 15th power. So we're going to take 8, we're going to take 1 and divide it by 3. So it's just, or sorry, 1 times 1/3. So it's 1/3, 8 to the 1/3 power. And then for x, it's 15 times a third, which is really 15 divided by 3. So it's 5. All right, and then the only thing we need to do here with this one is that if it's 8 to the 1/3 power, you need to see if you can simplify that one. And we'll do that over here. If you have 8 to the 1/3 power, that's the same thing as the third root of 8. Okay, that's 2. So final answer for this one would be 1 over 2x to the 5th power. So again, we've got 8 to the 1/3 power. That really means that's the third root of 8. If we check the third root of 8, that should just be a plain old 2. Okay, so if you have a variable and you have a coefficient, the thing that sometimes people forget is they'll forget to take the coefficient to a power as well. A lot of times people do this one and they'll just do, oh, I did 15 divided by 3. It's 8x to the 5th. They'll forget to do anything with the number. So you've got to include the number as you're going through these problems here. Okay, and the last one today. Got 9x to the 4th root of y to 3 over 2 power. Okay, so this one, we've got a radical and an exponential kind of mixed together. So the very first thing is, let's take this radical on the inside and rewrite it in exponential form. So instead of being the 4th root of y, let's make it y to the 1/4 power. Okay, now we can take this and work everything out. Technically, it's 9 to the 1st power, x to the 1st power, and y to the 1/4 power. So as you go through and do these, it's 9 to the 3 over 2 power. It's x to the 3 over 2 power. And for the y, it's 3 times 1 for 3. It's 4 times 2 for 8. So if you do the power to a power, we wind up with that for each little piece of it there. Okay, and then we just take it, break it down one piece at a time. So it's 9 to the 3 over 2 power. That is the square root of 9 to the 3rd power. Again, we can either do 9 to the 3rd power or we can do the square root of 9. So let's do the square root of 9, which is 3. So then 3 to the 3rd power would make that out to be 27. Yep. So with x to the 3 over 2 power, if we simplify that one, we're just going to take again, that power of x, we're going to take 2, divide it into 3. So I go 1 time with 1 left over. And if you were doing the y power, we're going to take 8 and divide it into 3. 8 will not go, which means we're just going to have the 3 leftovers on the inside. Okay, and again, everything on the top, these are how many get out. And these are left, oh, I said out and I wrote in there. These are how many get out, and those are how many are left in. So we've got 1x that will get out, no y's to get out, so then we're left with 1x on the inside and 3 y's on the inside. Okay, now here's the catch on this one though. That before we were able to kind of put all these things together for this one, but if this one is to the, because if we're rewriting this one is square root, correct? This one is eighth root. So those two things are going to have to be separate. We cannot put it together as one big radical because this is square root. This one's eighth root. So we're going to have to kind of do an eighth root of y to the third there. Maybe my bar a little too top on there. So for that one, again, just to clean it up a little bit, it's square root of x and then the eighth root of y to the third. Again, we couldn't combine, most of the time we were able to combine those together if it was the same radical, but because those are different denominators, they're going to stay different questions as you move through those.